When you're starting out training your own neural networks using Dreambooth or any other method, there's a decent chance that in some instances you might be overfitting your network. That means it always tries to output what it's been trained on. Let me give you an example. I've got plenty of those here. I don't know, let's go with this one. And you see, with my decently trained network, I prompted a highly detailed photo of a car, and this is what it generated. So, well, although not perfect, it's clearly a car. With my overtrained network, which has just been loading here, let's generate a high detailed photo of a car. And you can see it wants to try to turn this into an oil painting because that's what it's been trained on, abstract oil paintings. And you can see with this network, it even gets worse. This looks a bit like the paintings it's been trained on, but nothing like a car. But don't throw away your checkpoints just yet. If that is the overall style you're going for, we can still reuse it, especially when using it in the image-to-image mode. So what I want to do here is generate a portrait image in that oil painting style. So I'll load an image in here. That is yours truly. Let me just set this up for, I don't know, 60 sampling steps. Oil array is fine. Just increase the resolution, 768 by 768. That's what the network has been trained on. Let's just increase the CFG scale to 9. And the denoising strength here drives how much my neural network in the generation mode is allowed to deviate from this original image here. Let's just input some seed in here and let's generate this. And you can see that even without a prompt, this tries to turn this into an oil painting, which, well, you could argue if that is me. Let's give it a prompt as well. So let's maybe go for a minimalist abstract oil painting of a man and try regenerating this. And that's already getting close. I just want this to be a little bit more abstract, so I increase the denoising strength and let's regenerate this one here. Yeah, and that's getting somewhere. You might argue that this is barely recognizable as me, and I think you're right. So now my idea, what I want to do is, to make this image a bit more recognizable, I want to automatically compose parts of a human's face onto this image and reuse that as an input for the image-to-image, so it repaints the whole image. And the parts of the face I want to focus here are the mouth and the eyes. So for example, let's say I generated this abstract image. What I want to do is turn it into something like this, where you can see hints of the eyes and of the mouth a bit better, and maybe also hints of the overall face. And to automate this, what I will be doing is this. I'll be using OpenCV to detect where the eyes and the mouth, and you can see there are a few erroneous detections here, which we'll ignore, where those facial features are in the original input image. And then generate a bunch of elliptical masks, which will serve as alpha to overlay this original image onto an abstracted version of the image that's been generated in a previous step, something like this, which we can then run through the neural network once again with a bunch of slightly altered parameters to end up with something that has a bit more facial features present in the image. And optimally, you would be able to influence how much of the facial features come through in the final image and how much of the abstract image remains. Also, for our user to be able to dial this in and use this, I want to script this as a custom script for the Automatic 1111's web UI. So it should appear in here. And you can see I already implemented a bunch of those scripts. Now I don't want to be live coding here, as I find this a bit dull to follow. So what I'll do is I will take one of those custom scripts, namely the loopback script, and show you how I modified this to come up with this version here, which is a script with quite a bunch of parameters, admittedly. And what this will do, let me just close this, next to all those generation parameters that we'll have up here, that will generate the underlying first input, this abstract image here, it will then allow you to automatically compose facial features into that image. So let me just increase the eye and mouth preservation probability. So there's a chance of randomly copying over eyes and mouth. And let's decrease the second pass denoising strength, so just the composited images comes through. So let's hit generate, and you can see this is my second image. Also, you see there are a bunch of random ellipses appearing. That is because I've also added a number of ellipses that will be just scattered in there randomly. So let's increase those to, I don't know, 200 maybe. Hit generate again, and that's what it outputs. And this will be used for another round of this image-to-image processing here. So we'll feed that as an input in here. And then using this second pass denoising strength, which is set a good bit lower than the original denoising strength, to turn this input again into an abstract painting. So let's finally try running this with the final generation parameters. So that is our in-between image onto which the stuff gets composed. And then we'll feed that back into the algorithm to again create another abstract image. And you can tweak those parameters to your liking. So if you'd like more of these concrete features to come through, let's just decrease the second pass denoising strength here and hit generate again. And you can see now the eyes come through a bit better, maybe a bit too many of the random circles, and so on and so forth. You get the idea. So let's start coding, or rather script kidding and hacking together. So over in Sublime, I will open up the loopback script, off of which I based my custom. I called it double diffusion script here. So in here, I will go to Open File and then go to my install folder for Stable Diffusion. And in here, I'll have the script folders, and then I will base this off of the loopback script. And the first thing I want to do is save this as another file. So maybe save this as, let's call this double_diff.py. The first thing I want to do is up here in the scripts. This will configure the UI and also the name of the script. So in here, I don't want to call this loopback. That will drive how this script is being displayed down here when I select it. So I don't want this to be called loopback, but let's call this one double diffusion. And also maybe let's add a version like this. In here, we are sure that we're only displaying the script when we're in the image-to-image mode in WebUI. And down here, we are creating the user interface elements for this custom script. And then in this run method here, this is the main body of our script. In this case, we've got a loop which feeds the previous output of our neural network back into it as a new input image. And we're going to modify this in a second. The very first thing I want to do or need to do is import a bunch of libraries and make sure that they've been installed previously. In my case, just cargo culting on pip. And what I need, so let's maybe add a comment. Import libraries for compositing. What I need is a module of pill, the Python image library. So from pill, let's import image also, and that should be a capital I. I want to import a random function, so random. And finally, I want to import OpenCV for eye and mouth detection and also a bit of compositing work. So let's import CV2. Let's save this. Now down here, what you can see in the def UI, additionally to the loops and the denoising strength factor, some of which I just copied over here for the example, the denoising strength factor, I added a bunch of sliders. If we go back to our user interface, you can see the number of alpha circles, that's the number of randomly placed circles, then those circles minimum and maximum width, as well as their height, and also their minimum and maximum alpha, so they get randomized a bit. Also, the whole mask that we're generating procedurally will be blurred so that the edges will fade out a bit, and we can dial in the blur radius here. And then finally, I've got the chances of the eyes and the mouth being preserved in the mask. And finally, for our second pass in our neural network, we can dial in how strong the effect of the neural network should be with this denoising strength and how many steps will allow the neural network to run during its second pass. So to generate all those sliders, in this case, I will just copy over this block here. They're just using the standard Gradio library to generate a bunch of user interfaces. The important part being here, maybe, I don't know, the default values. Again, bunch of experimenting. Let's maybe set these to 80 instead of 10. And then down here, just make sure you return all those values. So I'll just be copying over this here into this UI here. Let's save this and maybe already check if that's working by going over to our web UI, going to the settings, reloading the UI, and then heading over to image, and without loading anything down here in the scripts tab, we should have a double diffusion V01. That's the script we're currently working on. And yes, you can see we are getting all of those sliders here with their default values already dialed in. All right, now for the main body in here. First, you can see I called this with all the parameters I created up here in our user interface. So let's just copy this line here and also take the eye cascade and mouth cascade definition with us. And what those two definitions do here is tell OpenCV where to look for the training data that its Haar cascade has been trained on to be able to detect eyes as well as mouths. And the training data for eyes and faces can be loaded in this way here. We'll just point it to its original repo and we don't have to manually do anything. However, for the mouth, I had to manually download the training data for the mouse here, put that into its separate folder, in this case in my AI folder, and just point OpenCV's Cascade classifier to this path here. So let's take all those three lines here and copy them over. And let's just replace this line here, like so. In my original code here, which I copied over from this loopback script, I directly start processing my images here. However, what I want to do is create a function which I'll be using to compose over parts of my original image onto another image. So that's what this blend2 function does here. And as an input, it takes an image called IM and a second image called second IMG. Up here, what I'm doing is I'm just trying to preserve my original image by just copying it over into this newly created variable and do the same thing with our blend image. So we preserve the second image here. Then I make sure that my image that I want to blend over is the same size as my original background image onto which I want to compose this. And then I'm referencing this blur radius, which I specified up here in those sliders, to create a tuple specifying the blur radius in X and Y. Next, and this is a misleading comment, it should read this. Next, I'm taking my input image, the image image with my face and converting it into another color space, as of course OpenCV does not work with RGB channels, but with BGR channels for some reason, of course. And that's what I'm doing here, converting this image to a color space. And you can see that for OpenCV, I need this to be stored as a NumPy array. So I'll also convert my blend image to a NumPy array and then create a new image, which I called Alice here for ellipses, which I will fill with ones, making this image purely white. Then I will go about randomly placing those additional secondary ellipses that I created. Remember those that I can drive with a number of alpha circles up here. And for that, I need the height and the width of our input image. So I'm just taking the image shape here and the colon to make sure that I only read out the first two values returned by the image shape here and not the value returned for its color channels. And then for all my random circles, I randomly generate a center here using the width and height. I also randomly generate the width and height as these two axes here, making sure to use the minimum and maximum radii for the width as well as for the height value down here. And then I also randomly generate an angle ranging between 0 and 180 as those ellipses are symmetric, as well as a random alpha value, and then draw my individual ellipse onto this ellipses image here, making sure to draw the full ellipses. That's what these two numbers are here, and filling it and not outlining it. Down here, I'll be drawing the ellipses around my eyes. So first I have to detect those eyes, which I can do with the detect multiscale, and I want to detect those within the face detect image. And what you could break out later if you want to add to this script here is the scaling factor in your Haar cascade. So a Haar cascade works by looking for certain brightness variations in specific patterns in your image. It does that multiple times in between scaling this image down by this factor. So this is one of the two driving factors of how sensitive your eye detection will be together with this. And this controls how many neighboring detection windows in the Haar cascade need to be positive in order to classify a certain region in our image as an eye in our case. So you could break out these two parameters here into the user interface and let the user dial that in. I, however, didn't do that and just resorted to hard coding these values in here, which in most cases seems to do a good job. And then for all the eyes that we detected in this multiscale cascade, we are extracting what this returns, the eye X and Y position, as well as the width and height of the window. So in this case, for this eye, for example, the X and Y would specify this point, and the width would be the number that I had to add in the X and the Y direction to get to this point, the other end of my rectangle in which my eye has been detected. However, I don't want to draw rectangles, but rather these silly looking ellipses. And ellipses are defined by a center point as well as a width and a height. So I'll have to convert these values into center point and width and height, which I'm doing down here after I check that a random value is below my eye probability in order to be able to properly use my probability slider, how likely it is that the eyes will come through and will be composited. So if that is true, I will calculate my eye center, which in this case is my X position of this point here, plus half the time of the width, so that's the X position, and we're going to do the same with the Y position, so this Y position plus half the time of the height, getting to this Y position, so we are centering our ellipses here. And down here, I decided to do that again. So basically what I can do is delete this thing here. Yeah, I absolutely don't need that. I just rewrote that down here for some reason. And behind that, I generated the width and the height. In our case, making sure that the ellipse is a bit wider than it is high. And we're making sure we are coloring this ellipse black. Right, let's delete this line. We don't need that. Down here, I did the same thing for the mouths, so I also don't need the mouth center here. And after I've drawn all my random ellipses and the eyes and mouth ellipses, I'm going to post-process this mask by blurring it out a bit and then multiplying it. So now the values within that mask don't range between 0 and 1, but between 0 and 255, and you know where this goes. We are now converting this to an RGB 8-bit image, 8-bit per channel, so every channel is between 0 and 255, and then converting that to a grayscale, which will then add as a mask to the image that we want to blend over our original image, making sure we set our original image's alpha to 1, so it'll come through. And then finally, we will composite our image that we masked with all those ellipses onto our original image and then return this. So quite a tour de force. Let's just mark all this function here and copy it over in here. So that's that. And now down here, we are back to our main loop here. So we are fixing our seed here in our processing in order to make sure we are able to dial it in manually, have our batch count set, and then our extra generation parameters. That takes over most of the parameters we specified up there in our user interface. So let's just copy that one over here like this. Batch size and number of iterations by default is set to 1. Our output images and info, as well as initial seed and initial info, are initialized to be 1. Grids and all images as well. And then I deviated a bit from our standard loopback script here. The first thing is our state job count, which is twice the size of our batch count because we are running our iteration twice. This is just mainly there to properly display our progress bar. Then we are initializing our first denoising steps. That's the one we set up in our standard default interface in image to image. Same goes with the initial denoising strength and the initial color correction if we set it up. Also, this is our original image that comes in this case the portrait of myself that I loaded up, which will then go into an array which I initialized to be 0. And as well, I initialized my random seed using the seed that I input in our UI. So let's copy this over and replace this with it here. Next, we are going into our main loop. So for each batch in our batch count, we reset our history and our initial steps here. Also reload our initial image, the portrait of myself, reset the initial denoising strength, and add our initial image to our initial images array here. So let's copy that over like this. And then our original loopback script had these loops defined here, which again is a loopback script in which you can dial in how many loops you want to run. I just deleted that and instead went manually through the 2 loops I want to do, setting up all the necessary internal variables such as the iteration number, the batch size, and we don't want to save this as a grid here. Here just as a debug, I printed out the initial denoising strength, which frankly I can get rid of. Then if I enable the color correction, color corrected my initial images. And then here is the important part. The processing.processImage is the way we are calling our neural net and inferring. That means creating our new image based on all those parameters. And after we check the status of our initial seed and incrementing our seed by 1 for the second iteration that we're going to run, we will extract the image that we just created from our process and append it to our history. So that's the first image we created. Now, with this first image that we created, what we do is we build another array called initme. Silly name. That's what happens when I try to bash together a script at like 1 in the morning. And I want to add to this initme list a single image, which I call initImage. And for this initial image, I will compose onto our initial image. Remember this portrait of mine that I loaded in? The process image. That means the output of our first inference using the neural network. And for that, I'll be calling this really long function that I defined up here. Remember the one with the OpenCV, the eye detection, and yada yada. So that's what I'll call here. And this new initialized image will be appended to this list here, which will then be fed as the initial image to our neural network, making sure I set up the denoising strength for our second pass according to what I set up in the user interface, using one of those elements I just created manually, using one of those custom interface elements we created, also making sure we are setting the steps number accordingly to the value we dialed in our custom user interface we created, and then running this through our neural network one more time. Again, making sure that after the process we increment our seed and appending the newly generated image to our history. And now we're back pretty much where we left off on this original script here. So now we're just checking if we enabled the grid saving, and if so, returning the grid as well as the final processed image. And we are done with that script. It's a lot to take in. In the end, when compared to our original loopback script, it's an additional 100 lines. The original loopback script has around 88 lines. This has 187. Most of it is down to that compositing script we wrote up here to auto-detect eyes and mouths and add a bunch of random ellipses to mask out our image, as well as configuring our user interface up here. And then the actual calling or the actual modification in our main loop here is not that bad. It's just basically calling our inference 2 times manually. And in my case, I didn't even bother specifying a loop for that, which I could have done. The interesting thing when you're looking at those scripts here is on the one side, how you define and how you configure those user interface elements, which is done like this, using the Gradio library. But also down here, which we have to get used to in our main loop, that the processing and the triggering of the generation of a new image is all done in this, what's by default called this p.object, which is the object that contains the main functionality of, in our case, Stable Diffusion, meaning the image generation, but also the configuration and setting up of the parameters used for that image generation. And if you want to know what's in this processing module that we're calling, you can find it in the installation directory of your web UI and then under modules. And in here, you can find this processing.py. And if we open up this here, you can see this is your processing definition, where you can not only find out which arguments the function is being called with or what it expects, but also in detail what it does, and sometimes even which parameter values or parameter ranges it expects. Maybe as of now, now there is a more proper documentation on the whole processing in WebUI. However, when I was researching this, I didn't find any, so I resorted to reading through this and just copying and bashing together the script like this. So I could now start copying over all this thing over here, my double diffusion here individually. In this case, I will just replace everything and call this double diffusion v.o2. Let's save this one here, and I will provide you with the script as well. Let's head over to our stable diffusion WebUI and go to settings, reload the UI to see if that transported over well. And in our image, let's scroll down here and we can see the double diffusion VO2. Again, let's load up a portrait of yours truly. Make sure we give this a bunch more sampling steps. Make sure the resolution is set to whatever you trained your neural net on. In my case, I'd like to increase the CFG scale, but also increase the denoising strength so we get a bit more abstract, just a fixed seed down here. And then, yeah, let's go with a number of 80 random circles, and let's make sure the eyes and the mouth definitely come through, and let's not deviate too much in our second denoising strength so the eyes and mouth actually come through. Let's generate and see if that works. And what I missed here is of course a prompt, so this does a very weird oil painting of myself, but then succeeds at composing the eyes onto it. And although that looks mighty creepy, I kind of like it, but let's go for a more minimalist abstract oil painting and rerun this. So now my oil painting, my initial one, is way more reduced, way more minimalist, and then I compose over my eyes and mouth, and again run that through my algorithm and end up with this one here. The point of this whole exercise being it's possible to wildly configure the behavior of WebUI and Stable Diffusion using those custom scripts and expose those parameters to a user. But also, it is possible to art direct and curate what Stable Diffusion is doing instead of just blatantly copying stuff that you found on the internet. And I think that's the power of this new tool, being able to hack it, to adapt more traditional workflows, such as face detection, eye detection, and compositing into it, and thus be able to even use models that are not perfectly trained and arguably would generate a lot of unwanted artifacts if not treated in that way. So I personally am very much looking forward to what you cook up using these custom scripts and bashing together a bunch of interesting scripts to modify the images that you infer using Stable Diffusion. And if you like what we're doing, want to support us, want to learn more about generative design, Houdini, Blender, a bit of Unreal, consider becoming a patron of ours, as it is through the help of our patrons that we are able to run Intagma. And for everyone already supporting us, thanks so much. With a very special thank you going out to Important Looking Pirates, Jellyfish Pictures, The Mill, Method Studios, Electric Theater, Pixonic, Random42, Rodeo Effects, Side Effects, Illusion, and Rafik Anadol Studio. Thanks so much. And as always, until next time, it is cheers and goodbye.